Good morning. In the last class, we were discussing about the volume of different objects. So here, the volume of cylinder is equal to, we have given as equation pi by 4 into d square into h. So where the d is the diameter of the cylinder and h is the length of the, or L is the length of the cylinder or height of the cylinder. You can take both. Okay. And surface area of the cylinder is, we can take it as pi d into L plus 2 into pi r square. So bottom and top together, we can take the pi r square plus pi r square, and the lateral surface is going to be the pi d into L. So total surface area is equal to pi d into L plus 2 into pi r square. And the pyramids and cone, we have equation, that is volume is equal to area of a cone, Yeah. So area of the base and to perpendicular height of the cone divided by pyramid or cone divided by 3. So which is, I'm going to get volume is the volume of the pyramid or cone, volume of the pyramid or cone. So whatever you can take any pyramid. So here the if it is square pyramid, then the area of the base will be taken as, area of the base will be taken as s square or x square side of the square into perpendicular height is perpendicular height of the square pyramid or axis height of the square pyramid divided by 3. So surface area is equal to area of the base plus perpendicular perimeter of the base into half of the length of the base length. So this is the volume and surface area of any pyramid. So now we will study about the wedge shape. So sometimes you might have the components, how component will be having the shape of the wedge shape. If you look at here, see this is a wedge shaped component if you have. So how to find out the volume of this wedge shaped component? So here wedge shaped components, yeah. Yes. So here I can find out the volume of the wedge shape, any kind of thing. So which is looks like this volume is equal to h by 3 into area of the base. So I can find out the volume of the wedge is equal to h by 3 into area of the base. So area of the base is looking like a trapezium. So area of the base is looks like a trapezium. So that's why I have taken the trapezium area, that is x plus y by 2 into b. So x plus y, b is the height of the parallelogram or trapezium. So x plus y by 2, this x and y are the opposite sides of the opposite sides of the parallel bases of trapezium. So x and y, sum of these two, and b is the height of the parallelogram. So that will be taken. So h by 3 into x plus y by 2 into b will give the volume of the wedge shape. Next, coming to the frustum of pyramids. Frustum of pyramids, how to calculate the volume of the frustum of pyramids. Yeah. So here, if I have taken a square pyramid, frustum of a square pyramid, so there will be two areas. That is area 1 and area 2. Bottom base is going to be the area 2, and top base is going to be taken as A1. And the height of this frustum of pyramid is taken. So then volume is given as h by 3 into A1 plus A2 plus square root of A1 A2. Square root of A1 A2. So if it is a cylindrical type, cylindrical frustum of a cone, frustum of a cone, then we can take it as volume is equal to pi h by 12 into d1 square plus d2 square plus d1 d2. So in the case of frustum of cone, it will be like pi h by 12 into d1 square plus d2 square plus d1 d2, or pi h by 3 into r1 square plus r2 square plus r1 and r1 into r2. So this is how we can calculate the volume of a frustum of pyramids and frustum of cones. And afterwards, we have studied about the sphere. And sphere, volume of a sphere is equal to 4 by 3 pi r cube, and surface area of the sphere is equal to 4 pi r square. And hollow sphere, volume is equal to 4 by 3 pi into r1 cube minus r2 cube divided by surface area 4 pi into r1 square minus r2 square. And segment of a sphere, as you studied in the circle plane figure. Similar to that segment of a sphere, we are going to find out what is the volume of a segment of the sphere. So it will be taken as pi h square by 6 into 3d minus 2h. 3d minus 2h. So this d is the diameter of the sphere and h is this segment height. Segment height, if you look at the diagram, so this is the segment height and the d is the diameter of the sphere. And also we discussed about the one problem. So where, see here, if I want to manufacture a stepped pulley whose dimensions has been given here, this is the three parts. I am totally have taken the sphere into three parts, that is A part and B part and C part. So each part is represents a cylinder, is represents a cylinder. A is also a cylinder, B is also cylinder, C is also a cylinder, and there is a hollow. So I have represented with the dotted line. There is a hollow portion. There is a hollow portion. So if I want to find out, if I estimate the material cost or estimate the if I want to estimate the material cost, so cost per kg, if the cost per kg is given, if the cost per kg, so cost per kg is given, cost per kg of the material is equal to, say for example, 60 rupees, say rupees 60. Then before finding per kg, so what is the total weight of the component has to be found out. So then we can find out based on that how many kgs this component weighs. So then each kg per kg, what is the cost of that component? Then we can find out the total material cost. So in that, if I want to find out the weight of the component, because the density is given here, so I need to find out weight or mass of the component is equal to density into volume. Density into volume. So here density is known, so volume to be find out, so that we can find out the weight of the component or mass of the components in terms of kgs. So for that we need to find out the volume of this component. So that's why I have divided into three parts. One is the A, B, and then C. So A diameter is given as 15 centimeter and 15 centimeter. This is 15 centimeter, and here 2.5 centimeter is given. So all dimensions are in centimeter. All dimensions are in centimeter. Okay, so length is 5 centimeter, 5 centimeter, and 5 centimeter. So here each component, part A is 15 centimeter diameter, part B is 10 centimeter diameter, and part C is going to be 5 centimeter diameter. So first, has a whole component, we are assuming that there is no hole at all. So take the volume of the cylinder of A, volume of the cylinder A. So volume of A I am going to find out. So as it is represent that in the form of cylinder, so we know that the cylinder volume is equal to pi into r square h, or pi d square by 4 into h, pi d square by 4 into h. So using that equation, see, pi by 4 into dA square into HA, that is pi d square by 4 into HA is the volume of this cylinder A. Part A. I have taken as a part A. So then by substituting these values, I will be getting around 883.57 centimeter cube. Similarly, for volume B is pi by 4 into dB square into HB. So dB, diameter of the B part, is going to be 10 centimeter, so 10 square, and H is going to be 5 centimeter. That is calculated, and also similar to that, volume of C is also calculated. So once you find out all these three ABC components, I have taken as this hollow portion as D. This hollow portion as D. Hollow portion I have taken as D. So D is the hollow portion, that is also represent the cylinder form, because it is a circular component, so it is also forms a cylinder form. So volume of the component D, that is VD, is also a cylindrical structure. So pi d square by 4 into h. So here D is the diameter of this hollow portion is 2.5 centimeter, and here h is through length of this cylinder. So that is about 5 plus 5 plus 5. So totally 15. So volume of D I have found out as 15. Length of the cylinder, that is 15. So 2.5 is the diameter of that. So totally volume of the D component is taken as 70. So this has to be subtracted from the total volume. So total volume is equal to volume of these three components, that is A, B, C, and then minus the hollow portion will give the total volume of the component. So total volume of the component I have got as 1311 centimeter cube, and then weight of the pulley equation is going to be total volume of the pulley into density of the pulley. So weight of the pulley is equal to total volume of the pulley into 7.2, it's the kg per centimeter cube. So here 7.2 grams per cc is given. So I am converting into kgs by dividing with the 1000. So density is given as 7 grams per cc. So here, if I it in terms of grams, I'm going to get, so divided by 1000, I will be getting as in terms of kg. So 9.37 kgs. So this is the total weight of the component, 9.37 kg. So we have given that per kg cost is going to be 60 rupees. 65 rupees is given. So cost per kg is given as 65 rupees. How many kgs it weighs? It is 9.37 kgs it weighs. So total cost is going to be total weight of the material into cost per kg. So it will give 650 rupees is the material cost of the given component, that is stepped pulley. So in order to manufacture the stepped pulley of the given dimensions, it will be cost around 650 rupees with the cashier and cost taking into consideration as 65 per kg. So similar to that, one more problem we have discussed, that is, so here asking the question is how many rivets can be manufactured. The question is how many rivets can be manufactured with the I have a total weight of the mild steel. Is given as 4 kg. I have a material with the 4 kg, raw material as 4 kg. So with this raw material, I want to produce the rivet. So rivet dimensions has been given. So based on this rivet dimension, so how much is going to be the weight of this particular small rivet is to be calculated. Once you find out the weight of this small component of this weight, then we can find out the how many rivets can be manufactured with the given raw material of 4 kgs of mild steel. So now see, density of the mild steel is taken as 8 grams per cc. So if you look at, once again, I am going to divide into 3 parts. So this is A and this is B and this is C. So A and C both are equal. And A is formed as, because the center is given below this point, so it is nothing but it is a segment of sphere. So segment of sphere, we have given the equation, that is pi by 6 into h square into 3d minus 2h. So we have volume of the part A, volume of A and volume of this is equal to volume of C also. A and C both are equal. So pi by 6 into h square into 3d minus 2h. So where h is the height of the, segment of the height of the segment of the sphere, and d is the diameter of the sphere. So diameter of the sphere is given as 2.8 centimeter, and h is height of the segment of the sphere is given as 2 centimeter. So substitute these values into this equation. So this is given as radius, that is from the center point to this end of this arc. So radius is given. So radius is 2.8 centimeter. Then the diameter will become 5.6 centimeter. Then h is given as 2 centimeter. So substitute all these values in this volume equation, which is pi into h square by 6 into 3d minus 2h. So once you find out this volume of A, then and volume of C, volume of B is nothing but it is a forms as a cylindrical structure. So cylindrical with a diameter of 3 centimeter and height of the 4 centimeter. So pi r square into h, or pi d square by 4 into h. So you can use any those two equations, that is pi r square h or pi d square by 4 into h. So pi by 4 into d is the 3 centimeter and h is the 4 centimeter. So by calculating that, I will be getting 28.27 centimeter cube. So next, coming to this volume of the C, as I told that volume of A and volume of C both are equal. So now total volume of the rivet. Total volume of the rivet, which will be taken as V is equal to VA plus VB plus VC, which is 26.81 plus 28.27 plus 26.81. So put together, I'll be getting 81.89 centimeter cube. And if I want to find out the weight of the one rivet, so when I want to manufacture one rivet component, how much is going to be the it weighs. So volume of the rivet I need to find out, and the density of the material given is also need to be known. So volume is given as 81.89 into 8 by 1000, which will give the 0.655 kgs. Means one rivet weighs 0.655 kg. I have 4 kgs of raw material. So assuming that there is no wastage, so how many components of, so one rivet weight is going to 0.655 kg. So how many number of rivets is going to be I'm going to manufacture? So 4 by 0.655 will give the 6.1. 6.1 is the, so assuming that it is approximated to 6 rivets. Approximated to number of rivets which can be manufactured is going to be 6 rivets. So likewise, I may ask you the number of rivets, how many can be manufactured, or what is the total material cost. So these are the two things which you can find out. So we can take one more problem on this estimation of material cost, with the different dimensions. Say for example, if I want to manufacture a component which is on the lathe machine, say for example, so there is a component looks like this, and okay, so then I have a step turning here. Okay, and of course the diameter is going to be same here. And afterwards I have a taper turning. Then this is the component. So I'll give the dimensions of this. So it is given as, total is given as 60 degrees. So this is cylindrical object. So I'm representing axis, and the diameter is going to be given as 50. This diameter is given as 50, assuming that all dimensions are in mm. All dimensions are in mm. Yeah. Okay. So diameter is 50 mm. Then this diameter, step diameter, is going to be 30 mm. Diameter 30 mm. And this diameter is also 50 because both are same. So diameter 50 mm. And here is this diameter, smallest diameter is given as 30 mm. The lengths are given. Lengths is going to be 6 mm, and this one is going to be, say, 25 mm, and this is going to be 6 mm, and this is going to be 75 mm. So this is the dimensions are given. So we need to find out weight of the material, and cost of the material, and we have taken 20 rupees per kg. Find the cost of the material if it costs 20 rupees per kg. Okay, so rupees 20 per kg, and density of this material is given as 7.85 grams per cc. So this is the data given. So based on the data, first write down the data. So what are all the data given? So one is, that is density of the material, which is 7.85 grams per cc, and he has given the cost of the material is equal to 20 rupees per kg. 20 per kg. Okay, so now if I divide this all into parts, because this is one component. Say this is A, and say this is B, and say this is C, and say this is D, and say this is E. So there are five components which I am going to take. So if I take this what I mean A component, so I need to find out volume of A, which is volume of cone. Volume of cone. So volume of cone, we have the equation which is equal to pi r square h, pi r square h, or pi d square by 4 into h. So here if you look at this, diameter of this cone is going to be 50, that we know, but h is unknown. See here I have not given this length. I have not given this length. This is h. So how to find out? But I have given the angle. I have given the angle. If you take the angle of that, so here half of that portion if you take here, so this is going to be 30 degrees. So and I have A and then B into C. So BC length is also known. From here to here it is going to be, so total length is 50, so it is equal to radius, that is 25. So by using, because I need to find out the AB length. So if I want to find out the AB length, so what angle can be used here? So tan 30 if I use, tan 30 is equal to BC by AB, opposite side by adjacent side, that is BC by AB. So BC is equal to 25, then AB I need to find out. So tan 30. So AB is equal to 25 by tan 30 will give the length of AB. Will give the length of AB. Okay. So now, once you find out the length of AB, I can find. So it will give 25 by tan 30 is equal to around 43.3 mm. I'm going to get 43.3 mm is the AB length, means that is the height. So volume of the cone is equal to pi into R. R is R pi d square. Directly diameter I will be taking pi d square by 4 into height is given as 43.3 mm. So by substituting all this into equation, or you can use this in terms of centimeter cube. So 5 square I'll take, and this is 4.33. So volume will become in terms of centimeter cube. So 85 centimeter cube. So I'm converting this millimeter into centimeter. So that I'll find out the volume of A. Similarly, volume of B. Volume of B forms a cylinder, right? So it is nothing but volume of cylinder. Volume of cylinder. So if you look at the diagram, so B looks like cylinder. So B and DC, even BCD, both all three looks like a cylinders. So B and D is equal here. B and D is equal. So I can find out volume of the cylinder. This is equal to volume of D also. Volume of D also. So if I find out pi, volume of the cylinder is equal to pi d square by 4. Similar to that into L, I mean length of the cylinder. Length of the cylinder. So if I take this volume of B, so D is the diameter is given as pi into 5 centimeter square. So 5 square by 4 and L. So L is given as it is 6 mm, right? So 6 mm in the sense I can take it as 0.6 centimeter here. So 0.6 centimeter. So I'm going to get total length is, total volume is equal to, it is 11.78 centimeter cube. So that is volume of B and as well as volume of D also. So volume of C is equal to, so that is also a cylinder. So volume of cylinder is equal, this is equal to pi d square by 4 into L. So we know that the diameter of that step turning, where we have performed the step turning here. So diameter is 30 and length is 25. So 30 means 3 centimeter, 25 means 2.5 centimeter. So 30 is the diameter. So 3 square by 4 into length is going to 25, so 2.5 centimeter. So put together, I'm going to get around 14.73 centimeter cube. So volume of D, as we know that it is equal to volume of B. So volume of D is equal to volume of B, so which is equal to 11.78 centimeter cube. Now total volume, before going to, because the E component is also, it's a frustum of cone. It's a frustum of cone. So the portion volume of E is a volume of frustum of cone. That looks like a frustum of cone. So we know that frustum of cone equation, that is pi by 4 into h by 3 or L by 3. So we can take it as h by 3 into d1 square plus d2 square plus d1 d2. We have used this equation. So here if I use this equation, now the diameter of the major diameter is, if you look at the component, major diameter is given as 50 mm, I think. Major diameter is 50, and see here major diameter is 50, and this is minor diameter is 30. So major diameter is 50 and minor diameter is 30, and length is 75. So I'll take it as 7.5. So 5 centimeter, 3 centimeter, and length is 7.5 centimeters. So by using that equation, by using this equation, so where d1 is equal to 5 centimeter, d2 is equal to 3 centimeter, and h is given as 7.5 centimeters. So by using that equation, so pi into 7.5 divided by 12, so into 5 square plus 3 square plus 5 into 3. So here I'm going to get 63.45 centimeter cube. So I got all the components volume. Then total volume is equal to VA plus VB plus VC plus VD and plus VE. So all the volumes you have to sum it up. So total first volume of A we have got 85 centimeter cube. Volume of B and D both are equal. So I'll be getting 11.78 plus volume of C I got as 14.73. Then volume of D once again 11.78. Then this is going to be 63.45. So if I add all these things, I'll be getting around 186.74 centimeter cube. 74 centimeter cube. So total volume is 186.74 centimeter cube. And we know that density of the material is given as 7.85 grams per cc. So weight of the material is equal to total volume into density of the material. So total volume which I have got is 186.74 into what is the density is given, 7.85 grams per cc. So it is, you are going to get in terms of grams. So by dividing this equation by 1000, I'll be getting in terms of kilograms. So I'll be around, roughly I'm going to get 1.46 kg. 1.46 kg means if I want to make that component, I need 1.46 kg. 1.46 kg. So if I take the material cost, because I know the cost per kg, material cost is equal to weight of the material into cost per kg. So what is the weight of the material which you have? 1.46 kg. 1.46 kgs, and cost is 20 rupees per kg. So put together, I'm going to get around rupees 29.20. So this is the one component cost. This is the one component cost. Okay, right. So now we'll go with one more problem on this, so that different volumes we are going to face. Yeah. So I'll take a component which looks like this. Yeah. This end is looks like a segment of a sphere, and like this, and it has a diameter is 60. Is cylindrical component, and I have conical component at the end. I have conical component at the end. Okay, so now this is the axis length. Okay, axis is given. So I given dimension here, it is all dimensions are in mm. One more is all dimensions are in mm. So here is 30, and the diameter of this cylinder is given as 40. Okay, and the diameter of this is given as 60. Diameter of this is given as 60, and of course it is given as angle is given 90 degrees. Angle is given as this is 90 degrees given, and this length, if I have, it is mentioned here, is this is 25. So this length is given as 40, and this length is given as 15, and here is not mentioned this. Here is not mentioned. So here, if you look at this portion, here as given in the problem, this has like this. Means there is a fillet here. There is a fillet here. Okay, like this. So this fillet radius is given as 10. This fillet radius is given as 10 or 10. So 10 mm. So now this is the component which I need to make, and here is given as 200 articles I'm going to manufacture. 200 articles I'm going to manufacture here, which is I need to find out the weight of the component, and also density of the material is given as density of this material. Density of this material is made up of, say, mild steel. So density of the material is given as 7.8 grams per cc, and material cost is given. Material cost is given, which is rupees 12 per kg. So here, if you divide these components into to find out the volume, each component I am going to name it. So this is A. So this is a A, and this is B, and say this is this fillet I'll be taking as C. This fillet I'll be taking as C. So that is fillet. Okay, C is the fillet. That is also we need to find out, because this portion is different, right? This portion is different. Okay, so that this forms completely cylinder up to this, but we are filling with the fillets, so that also will be taken into consideration. So that is C part I have taken as fillet. Then this as a D, and this as a. So there are 5 components. So A forms as a segment of, A is a segment of sphere. A is segment of sphere, and B is cylinder. Okay, and C is fillet. So we know that fillet, how to calculate the fillet radius, fillet volume, and also D is a cylinder once again. E is equal to, then we have the, this is a cone, this is a cone. So there are five components. There are five components. So in the last class, we have discussed how the fillet volume can be calculated. Fillet volume can be calculated. That is, fillet volume is equal to, so we can take it as 0.215 into r square into mean diameter, So by using this equation, we can find out the fillet. We find out the fillet volume. So you try this problem for the next class. Today I'll stop here.